So for this problem, write two different functions with the following degrees and zeros, and then sketch. So I'm going to write f and g, two different functions that have a fourth degree and this 0, which is a multiplicity of 2, a negative 4, and a 0. And I also, besides making two different equations, I want to sketch each. Now I have infinite of equations I can make. So when I make two different equations, I want to make two uniquely different that still follow the rules. So let's start with understanding our zeros. So for both of these graphs, they're going to have the exact same zeros. Now when I say multiplicity of 2, you have to understand that's going to be a bounce. Okay? Means at 3, it's going to have a bounce. That's what multiplicity of 2 means. So let's put a dot at 3 for both of these, at negative 4, and at 0 for both of these. Let's do the same dots. Because don't both graphs have to hit the same spots? No matter what you do, those zeros are defined. So that's stuck. Fourth degree, well, since I have a fourth degree, doesn't that mean I have two options? Couldn't it be this, or couldn't it also be this? Aren't those both fourth degree in behaviors? Now, if they look like this, isn't our lead coefficient going to be negative? And for this, isn't our lead coefficient going to be positive? So won't this be a lead coefficient negative? And won't this be a lead coefficient positive? So basically, could I, for f, maybe make a front lead coefficient negative, and over here make it a positive, so I have two unique graphs. One going up, one going down. Okay. And the second one, I'm going to make a positive 2, just because I want to. But I want them to be uniquely different. Now, first of all, don't they both have a 0 at 0? And if you have a 0 at 0, isn't that simply x? So don't they both start with an x? Now you could put x plus nothing, but that's kind of pointless. Next, let's do negative 4. So negative 4, going to the opposite, so won't that be a plus 4? Each of these have an x plus 4. All right, and then we have this 3 here, but it has the bounce. So a 3 with a bounce, well, a multiplicity of 2, what that means is I have x minus 3. Remember, it's the opposite of 3. But doesn't a square create a bounce? That's a multiplicity. So I have an x minus 3 with this squared. I just wrote two different equations. Now, by the way, could I flip-flop these two? And put the x minus 3 squared and then the x plus 4? Yeah, the order at which you put them doesn't really matter. But here I made two uniquely different graphs. They both have the same zeros and they're both fourth degree, but they'll look quite different. So let's graph this one real quick. We're going to quickly graph the first one. All right, I know because I have the negative, wasn't it going to look like this on the edges? And don't I have a bounce at positive 3? So if I have a bounce at, isn't this positive 3 right here? Isn't it going to go like that at positive 3? And then over here, isn't it also going to go down? So if I go through that, here's what it's going to look like. Something like that. I have my bounce at positive 3. And I went through the other zeros, and they're both going down because of the negative lead coefficient. Now for this one, I have the same zeros. I'm still going to have a bounce at 3, but isn't the second one going to be going up and up? So for this bounce, we want to be bouncing like that, upward. And then won't this side be going up? So won't it look something like that? So I just graphed, and I made two different equations with the same characteristics given, but they look uniquely different. Now, to be careful, technically, because I put a 2 there, shouldn't these maxes and mins be higher than this one? Technically, but I'm just sketching. But the bigger the number, technically what that means is this min and this max will be higher. The bigger the A is, the bigger the number in front. But that's not a big idea. That's just something to kind of point out. Good luck with this.